Hi everyone, this is my Lab 2 report. This is a quick overview of what I'll be talking about today, starting with the introduction. So the purpose of the lab is to compare the point charge model and the line charge model when determining the approximate charge of a piece of tape. So some of the initial assumptions is to ignore air resistance and assume each U-tape has the same amount of charge evenly distributed along its length. So some of the fundamental physics principles we used were the Coulomb's law, electric force, gravitational force, Newton's second law, all with the formulas as seen in the slide. And we also used the electric field and superposition models. So a quick overview of the results is that the charge of the top tape with point charge model is 1.37 e to the negative 8 coulombs, whereas with the line charge model, it was 2.79 e to the negative 8 coulombs. And I believe that the line charge model is a much more accurate approximation of the charge of the piece of tape. And we also found the magnitude of the electric force and gravitational force to be the same, and it was equal to 0.002009 newtons. So now moving into the experiment that we did in part 1, we see that the methodology was first to create the charge of the U-tape, so creating the base tape and making a U-tape and doing that twice. Then we would check the tape's charge. So we did that with several different objects and found it to be positive. And lastly, we calculated the charge in the following manner. So we used the initial conditions where the system was the top U-tape and the surroundings was the bottom U-tape and Earth. And we also found the length, width, mass, and distance between the tapes as seen on the slide. And so then we actually calculated the charge of the tape by first finding the magnitude of the gravitational force on the U-tape, then finding the magnitude of the electric force on the U-tape, and then this is the charge of the U-tape from the first lab. So moving into the computational model that we found for lab 2, we first put in the constants that we needed, such as the gravitational constant and the mass of a piece of tape and the charges that we needed. Then we created the electric field function as seen below. Next, we also created the line of charge, which was the function given. And then we also created the tapes as a visual representation in GlowScript with different point charges. And next we calculated the electric field and electric force as seen in the following way. And lastly, we calculated the net electric force and the gravitational force. And we also found the percent difference between the magnitude of the electric and gravitational forces. So this is the code output that we got. So when I used the charge from lab 1, I found quite a large difference in terms of the electric and gravitational force magnitudes. And using a new Q with trial and error in lab 2, I found the percent difference to be a lot smaller. So moving into a more detailed discussion about the results, we see that comparing the point charge and line charge models that there's quite a large difference between the approximation of the charge of the piece of tape. And in the point charge model, we see a 122% difference between the gravitational and electric force magnitudes, likely meaning our approximation of the charge of tape is inaccurate. And then in the line charge model, we see only a 0.05% difference, meaning our approximation is likely closer to the actual value just because our electric and gravitational force magnitudes are very similar, almost equal. So some possible sources of error is that the charge distribution is actually not uniform on the tape, and I could have used a higher number of pieces to break the line charge into to find a more accurate approximation of the charge. And so moving into the what if question, we found the percent difference between our results of the charge in the point charge model and the line charge model to be 68.2692% different. And so why these estimates differ? This is likely because these are two different modeling techniques to come up with an approximation of a charge. And the value that's likely closer is the line charge model value, just because we're more accurately able to see that the gravitational and electric force magnitudes are equal. And we see that we're able to actually split the length of the tape up into more individual point charges to account for the actual length and distance of the tape, which is not what we did in lab 1, likely making sure that the line charge model is more accurate.